Okay, we'll start. Today is 27th August. Okay, and we are talking about list. So this is how we define a list, empty list, isn't it? And if you do the size of this, if I say print length of list one, okay, you would get zero, of course, right? There's nothing here. So see, there are, when you talk about data structures, okay, there are different types of data structures. Okay, there are many. Okay, but there are two common data structure that we use. Okay, one is called rows or queues, rather, not rows. QUEUE, right? And stack. Okay, so what does queue means? Okay, queue means, okay, when you stand in front of a queue, right, for booking a movie ticket, or okay, or booking your train ticket, or getting in somewhere. So if you see the queue, okay, it is based on first in, first out, right? Or we call it as FIFO. What does that mean? So if you are first one to stand in the queue, you will be the first one to go out of the queue, correct? Okay, if you're second one to stand in the queue, you will be second one to go out of the queue. Agreed? Okay, so that kind of implementation is called queues. Then stack is, okay, we call it as last in, first out. Okay, last in, first out. Okay, so when you, let's say, in any party, right, you put the plates for, let's say, for buffet, right? So they'll put the plates somewhere, isn't it? So plates are stacked. Okay, so the first plate that you keep will be the last one to take out, isn't it? So let's say the plate is empty. So somebody cleaned the plate and got the plate and put it on the table. That plate was first to come in, correct? But let's say now somebody else cleaned the second plate, and now the second plate is put on top of the first plate, correct? Now someone got out and got this third plate and put it on top of the second plate. So what happened? The first plate was the first one, of course, to be put on the table. But when you take out for eating, you will not lift the plate and take the last one, isn't it? You will take the one which is on the top of the stack, right? That's called stack. Okay, so queue will have both ended open. So it comes from one end and goes out from another end. Stack will have one end closed, right? So you come from the end, same end you take out. So that's what happens is, okay, when you put something in a jar, right? Let's say you got biscuits packet and you put biscuit packet in a jar. The first biscuit packet that you will put in, that will be the last one to take out, isn't it? Because you'll have more packets on top of it. But when you want to eat, you will not, dump the jar and take the last one, right? You will pick the one which is there on the top. That is called stack implementation. Okay, stack implementation, last in, first out, or first in, last out. Okay, for philo, can call it philo or leaf. Q is first in, first out. Okay, so we have to implement, okay, Q. Okay, and we can also implement. So I'll show you how to implement a queue. Okay, and next you have to use the same logic to implement stack for your assignment. Okay, got it? So I'm going to say here, implement stack. Okay, and I'm going to implement this. So see, there are 4 different functions. Okay, I think we have done only 2, right? But there are 4 important functions that would be required here. Okay, so what happens when you get in? what happens you when you come out? How do you come out? Okay, so you have append, right? What append does? Append method adds at the last, correct? Okay, then what is the next one? Insert, isn't it? So what does insert do?
It adds it anywhere in between. Like if you, for example, you give 2 comma 20, it adds 20 in position 2, inserts it.
Right? So it inserts at a given position. So if you look at this situation, we would not need insert to implement this, right? Because by default, okay, you go at the end in both up queues and the stack. Okay, you will go at the end, isn't it? In both implementation, you would go at the end, isn't it? So it's not a we won't be using this, right? Now now we have two other functions. One is pop. Okay, what pop does is, okay, it removes the element, okay, at a given position. Okay, so it will remove from a given position, right? Okay, and what would this remove? So this will look for the value. So removes given value. Okay. Now using these four. Now if you see here, we won't need this because when we take out, right, we don't see. Okay. Okay. Now unless and until, let's say, you want to see if there is a single queue and you want to have ladies first, let's say, suppose. So if you'll see if lady is even at 10th position, you will go and pick the lady from the 10th position. So this is example of remove where you look for the value. Okay, so let's say you don't want you want to the negative values would be done at, say, preferred way, let's say. So then you will check if is there a negative value there or it's a negative value. Then you remove irrespective of position, first or last. Okay. Similarly, insert, you don't insert at specific position, right? Because in the stack, it will go at the top. In the queue, it will go at the back. Simple. So we need only append and pop. Okay. The way we will remove them is different, but it is, we use these two functions only. Okay. So I'm going to, okay, write a while loop. Okay. So while true. Okay, and you have three options. Okay, so print three options, and if you include exit, four options. Okay, you want to display first, display the content of the queue. You want to see who all are there in the queue, correct? Then you will say, then we will add a new member. See, the thing is, you will not ask which position to add. Okay, you just say add a new member. So the new member should be added at the end, append, simple, right? Now you have a third option. Let's go to the next line. Print. Third option is remove a member. So when your work is done, let's say you got your ticket, you go out, right? So you won't ask which member to remove. Automatically you will remove, in this case, 0, pop 0. Simple, isn't it? Whoever is at the first position is needs to be removed. Pop 0. Append and pop. Simple. And our queue implementation is done. But in stack, you have to think. You cannot do pop 0. Pop 0 is first. You have to do something else. So remove the member. And then finally, I'm going to say exit. Okay. Okay. So now you will read the choice. Okay. So I'm going to say int of input. Enter your choice. Now, in such cases, right? Anyway, we are not going to use these numbers for comparing or printing, right? So you can read it as string, okay? Because if the user enters A or B, our program will, okay, our program will give error, right? So anyway, we are not going to, add values, right? So it doesn't matter whether it's a number or a string, correct? So this makes sense. Okay, so now told you first thing first, if ch equal to 1, because I'm reading this as integer, right? Perform something. Okay. Then elif ch equal to 2, perform. Okay. Home. Elif ch equal to 3, perform something. Elif ch equal to 4. Okay, you say break, right? And else you say invalid. Okay, so actually this is new thing has been updated. So if I say invalid, get invalid option. Okay, our structure is ready. So when we run this, enter a choice 1. Okay, R invalid option, isn't it? And if I see 4, exit. So our structure is ready. Now let's go back. So before print, we'll put our list, which is queue, right? So I'm going to call it as my queue or whatever, right? My queue equal to, okay, empty list. Okay. Now, if you are adding, okay, member, so I'm going to say print and not print, right? Input directly we can say input. So inp equal to input. Okay. Enter the number. Okay, and you simply say my queue QUE, okay, dot and input value, whatever it is, right? Anyway, we don't have to worry about whether it's string or integer or whatnot, right? But not see. Now I need to remove it. The remove is a little tricky. Why? Because if the list is empty, then you can't remove anyone, right? So here I have to check if len of my queue, okay, len of my queue is less than equal to 0, you will say print, sorry, there is no one in the queue. Okay, and then you can say continue, isn't it? Else my QE dot pop. Remove first element, right? So first element is removed every time. Okay. Now this is simply printing, right? The current members in the queue, okay, slash n, and I'm going to say my queue. Simple, isn't it? So when I run it, enter your choice. I want to display the member, right? You can add a if condition here. Okay. When I say display, what happened? Oh, display is one. Oh, you guys are not looking. I put display in log code in 3 and 1. What are you? See, I'm adding here in when I should be displaying. So this is the logic for CH3. So what we'll do is, this is adding, right? So I'll say 2. And this is delete, right? Option 3. And CH, this is display, right? 1. So enter your choice. I said display the content, right? So current members, instead of displaying blank list, you can even check the length, right? And say that sorry, queue is empty. Okay. So now let me enter a member. So I'm going to enter. Choice to enter the member to be added. Section is added to the list. Next, second option. Okay, I'm going to say 555. Okay, enter a choice. I want to add a member. 2. Right? 555. Now, if you display the list, you have Sachin and 555, right? Let me enter one more. Okay, I'll say 2 and I'll enter Seva. Okay, so now we have 3 members in the list. Okay, next we will say remove a member. So by default, which member should get removed? We added Sachin first.
Sachin.
He should get removed, right?
Yes.
Right. Remove the member. Okay. Now you display the content. Okay. Sachin is gone. All right. So display the content removed. So I'll say 3. Okay. I'll say 3. And I'll say 3 again. So both are removed, isn't it? If I say 3 again, it should say, sorry, there's no one in the queue. Right? So this is how you can implement the queue concept. Okay. So this is a concept, and depending upon your, okay, let me put 4 first. Depending upon your business case, the logic where you need to use it. Okay. Now similarly, you have to implement stack. Is it fine? Yes, no.
Yes, sir.
She's still sleeping. Okay. So next one, okay. See, we discussed that strings are immutable. Correct? What does that mean? It means you cannot change the value of string. So if I say str1 equal to hello, okay, and I try to say str1 of 1, okay, equal to e, okay. E, right? This will give error because you cannot edit the value here. Okay, this is what, okay, saying that it is immutable. You can't edit it. Of course, you can create a new variable and you can do that, but you cannot. Now, if you have a list, right, and list equal to, let's say you have H E. I don't know why sometimes this 2 dots appears and L, L, O. Okay. The O has double dot on top of it. Okay, so this is our list. Now, if I want to remove or I want to update list one of one equal to, let's say I want to do E. Okay, or K. Let's say, at cloud. Okay. Now, if you print list one, you will have the updated value, isn't it? Okay, so this is says that lists are mutable. Okay, strings are immutable, you can't edit, but list can be edited, it is mutable, right? Okay, so that is one difference between string and list. Let's look at another example. So this is my list one, right? So I'm going to copy it again and put it here. I'm going to say list one or list two equal to list one. So list two will also have the values of list one, isn't it? There's one way, there's one more way to copy the content of list one to another list. So I'm going to say list three equal to list one dot. Okay. Okay. So now if you print, so I'm going to say print one list one list one, right? And let's print all the three lists. Okay. So if you go and see, this is what we expect, isn't it? Because we have copied the content. Okay, and say list two equal to list one and list three equal to list one dot copy. So values will be so values will be same as list one. Okay. Now, if I make any changes, let me add something to list one. Okay, I'm saying append, and I'm saying let's say K. K should be added at the end, isn't it, in list one? Let me add something to list two also. Okay. Now let me add something to list three also. Yeah. Now let's print list. So one I indicated before making the changes, and I'll change it to two here to know the output after making changes. Now when you run and see, tell me what do you notice?
Sir, it is added in the end.
Okay. That we already know, right? Anything that we don't know so far? Anything that we learned new?
Sir, it is updated with this uh, previous list, sir.
It's all in front of you. Why are you taking too much of time?
Sir, in list 2, like in list 1 we said list 1 append k, so it said k, and list 2 it came as k and l, but in list 3 it's just showing hello and then m, only m, it's not showing k, l, and
Okay.
even list 3 should come as hello k, l, and then m, right?
Anything else?
And in list 1 we just said append k, and even l came in list 1.
Okay. Right. What else? So tell me, when will you use equal to, when will you use copy?
So we have used equals to adding in for second list, sir, and copy we have used for third list.
Sorry.
So here we are for writing second list we have used equals to, and for writing in third list we have used copy.
So see here, though we are calling list 2 and list 1 separately, right? Sorry. So though you're calling list 1 and list 2 separately, right? They are very much linked. K was added to list 1, still it is showing in list 2. L was added to list 2, still it's showing in list 1. That means list 1 and list 2 are pointing towards same value, same list. They are not different. Though names are different, but it's the same list. But copy will create a duplicate copy of it. It's like photocopy. Okay. So the moment I say copy, okay, it will create a copy. Okay. So when you add M to list 3, only list 3 is impacted. List 1 and list 2 has no impact. So if you take a photocopy, at that very moment, what is there in the original will be copied to the duplicate, right? But after Xerox, if you make any changes to Xerox copy, original will not have any impact. And if you make any changes to the original, duplicate Xerox will not have any difference, isn't it? So it's like creating a duplicate copy and then that's it. They're separate, right? But when you say equal to, they point to each other. So this is what we call it as deep copy and shallow copy. Okay, this is your deep copy. It just copies everything and connection is cut. This is shallow. Shallow means it's not really copy. It just maintains the same link. Make sense?
Yes, sir.
Okay, so that's the difference between copy and equal to. Okay, though they look like a copy, but they are really not copy. They are like, it's like creating duplicate values. Make sense? Okay, great. So, okay, so when you want two copies to actually point to each other, then you use equal to. When you just want to create a duplicate copy and move on,
Then use copy.
copy, right? Okay, great. So there are a few more. Let's discuss those. Okay, one of them is, or last one I would say, is clear. Okay, so if you want to clear the list, I'll say list 3 dot clear. Okay, we can do it here itself. Okay, and now if you print list 3, okay, the list 3 will not have any value. List 3 as a variable will exist, but it will not have any value to it. Then we have something called as del, delete list 3. This is to delete the variable. Now you can use this del for anything. Del integer, del string, del any variable. Okay, you can use del. And when then is like delete. And when you now what happens, it will delete. And now when I try to print, okay, it will show me not defined, as if list 3 never existed. Okay, as if list 3 never existed. List 3 is not defined. As if it never existed, right? So that's the use of delete, and you can use it for integer also. Okay, delete integer. So if you delete integer, the variable is gone. You can't even access that variable. Make sense? Okay. So this is about delete. Then or clear, right? We're talking about clear. So it will remove the values, but content, the variable will exist. Okay, it will have 0 size. And then you have count. If you want to count something, I want to count how many L is there, right? So I can say or count, right? Or directly let me print it. Or let's put count here. Count equal to, okay, list 1 dot, okay, count, and you put L here. And then I'm going to print the count value. So it will tell us how many L is there. So you can actually count. Okay, so we got 3 L, isn't it? 1, 2, and 3. Last one is also L. So it counted number of L's for us. Okay, if you want to add to list, okay, so we have seen we can say list 4, or we can use list 3 now because we have deleted the older list, right? I can say list 3 equal to list 1 plus list 2, right? But if you want to create another list, let's say, if you don't want to create another list, you want to add to the existing list. So instead of saying list 1 equal to list 1 plus list 2, you could say, okay, instead of this, we could say list 1 dot extend list 2. Okay, now when we print list 1, okay, you will have list 1 and list 2 combined. Okay, so it combined. This is your list 1 followed by list 2 values. Okay, if you want to find the index, I want to find index of say O, right? So again, I can have to say print list 1 dot index of O. Index. O. I don't have a habit of doing in Colab. I have more used to PyCharm, but my laptop is still not back from repair. So you get 4. So there are, so it is at 5th position, right? So this is your first position, H, E, L, L, and this is your fifth position, right? So it tells you the index of first occurrence. Okay, index of first occurrence. Now I want to find index of all the occurrences. Tell me, what should I do?
So like we had colon.
Colon, no. Okay, so see, we know using count how many occurrences are there. So we need to
Len.
run the loop. Okay, now here you can also define, okay, index. Now I say here, say 5. Okay, what happens? Okay, it says, okay, so along with index, okay, so if I give 5, it means I want to start from 5. I want to start from 5. You can also define ending value. Let's say 11 is there, right? You need to put 10. So I want to see if O exists between position 5 and 10. If O exists between position 5 and 10. So when you run it, you get 0, right? Minus, I mean, the O is not there, so you get error. Okay, because between 5 and 10, we do not have any O. Okay, so along with index, you can mention, okay, index can take 2 other values, okay, which is your start value. Okay, it will search in the string after this number or after this index, right? Not number. Okay, second value is end value, not values. Okay, it's only value. Search till this index. Good.
And
So now you tell me, how will I find? Okay, so see, we know using count how many values are there. So first you have to perform count. Okay, so I'm going to say string to or value to search, right? No, it need not be string, right? It can be any value. Value to search equal to, let's say I put L. I want to search L in the list. Okay, so first thing I'll do is I'll do the count. Count of what? Count of this, right? Home shift end. So first I'll do the count, right? And I'll put value to search, right? Where to put L. Okay, so this will tell me the number of values, right? Now I'm going to say print, okay, the indexes of, okay, this are, okay, and I want to print this in the same line. So what I'll do, I'll say end equal to 0. Okay, I want to print in the same line the output also. So for I in range count, right? So loop is going to run 5 times. Okay, so how to find the first index? Ind equal to list 1 dot index, right? And this will give me the first index, isn't it? So I need to print this now. I need to print this index. I'm going to say print ind comma end, right? Still we don't want to go to the next line. Okay, you can put 2 space. Now in the next iteration, I need to search from, okay, this particular value onwards, right? So what I'm going to do is I'm going to put another value called start search, and by default it is 0. Okay, so I'm going to say start search from 0 in first time, and second time it's going to be start search plus equal to 1. So now you start search from next character. If you found at 10th position, start searching from 11th position. If you found at 5th position, start searching from 6th position. Isn't it? Okay. So, okay. Hopefully this should work for us. Let's see. How many L's are there? We have, no, it didn't work. It did not work. Clearly it did not work. So 0, 1, 2. 2 is fine. So first of all, it says L4, right? That's not right. No, this could be something else. Okay. 6, the L1, 2,
4 is for
4, 5, 6. So 6 is correct. Okay. And positions are 1, 1, 1. Okay. Start search is 0. What am I printing? I'm printing IND. This is correct. So see, first occurrence is 2. So it makes sense, right? Second one, oh, you guys also are sleeping like me. See, when you find the first index, the second index should start from that particular point, isn't it? Index plus 1. Okay, not start search plus 1. Start search is 0. Okay, so now we know the position is index, right? IND. So from here onwards, I have to check, isn't it? Right? Now you got it right, isn't it? You can check. So 2, 3. So see, when I found the first value at position 2, the next one should start from 2 plus 1, 3 onwards, not 0 plus 1, right? So start searching from index plus 1 and you will get this value. Make sense?
yes, sir.
So this is how you can search for all values. Okay. Now, there are two more functions which we need to discuss. Important one. Okay, one's called reverse. Okay, reverse will reverse the content. Okay, so if I say print list one dot reverse, okay, and when you run it, okay, so what does it print? It prints none. Okay, so first of all, I need to put a print here. We are done. So we need to print, go to next line. Now, when you say list reverse, it does not return anything. Like or unlike your count index. Count index is returning the value, like number of occurrences or which position the value is found. Okay, so next one, reverse and sort, okay, will not return anything. It will quietly reverse the list value. Okay, it will reverse list value quietly. It does not return anything. Okay, so what I'll do is I'm going to say list one dot reverse. Okay, and then you print the list one itself. List one is changed now. Okay, the list one values are reversed. You see, L K O L L, right? So it has reversed the list. Then we have something called as sort. Okay, it will sort the list. Okay, so if I say sort list one dot sort, and when I print list one, so this case the list values are sorted. You see, E comes, then H, then K, L, 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 O, O. It has sorted from the content into the increasing order, right? Smallest value, then larger, larger, larger. If you want to sort in decreasing order, so one option is you do the sort and then you reverse the list, right? If I do reverse the list here, if you print the list 1, okay, it will be in the decreasing order. Highest will come here, right? Or what you can do is you can simply put reverse inside sort. How? You say list 1 dot sort reverse equal to true. Reverse equal to true. Now it will sort in the reverse order. Okay. So reverse will simply reverse the content. Sort will default sort in increasing order. If you had numbers, you would have had 1 first, then 5, then 10, so on. If you want to sort in decreasing order, you inside the sort you just say reverse equal to true, and your list will be reversed. Okay, with that we finish list discussions. Any questions here? Okay, you guys please practice from the book as well. Okay, there are examples in the behind the book and also in front. Okay, so please practice from the book. Okay, is that fine?
Yes, sir.
Yes, sir.